Draw an epicycloid of a circle of diameter 50 mm which rolls outside a circle of diameter 180 mm for one revolution. Also draw a tangent and a normal to the epicycloid at a point 135 mm from the center of the directing circle. Okay, first we are going to learn what is epicycloid here. Okay, epicycloid means it is a curve. It is a curve traced by a point on the circumference of a circle rolling on the exterior of another circle. That means here there will be two circles. One will be the bigger circle, one will be the smaller circle. You can see here, if I consider a point on the circumference of this smaller circle, as it rolls over on the surface of this exterior of this another circle, it is tracing a curve here. Say if I want to join, just for an example, say from here to here, then from again here to here, like this. So the curve which has been traced by a point on the circumference of this circle, as it is rolls over this another circle. So what is that curve what we got? Okay, that we called as epicycloid. Okay, epicycloid means it is a curve traced by a point on the circumference of the smaller circle which is rolling over the another bigger circle. So this is the bigger circle on which it is rolling for one complete revolution. That the curve what we get, that we called as a epicycloid. Okay, as per this question, we have two circles. One is of diameter 50, another of diameter 180. So that means we have the two diameters. One is small d. Small d we have 50 mm, and capital D we have that is 180 mm. So if I am drawing the bigger circle, we have to find out an angle. For how much I have to take an angle. For that we consider that as a theta. Okay, theta is equal to small d by capital D into 360 degree. So if we are substituting the values, the angle what we get, that is 100 degree. That means first I will take a radius r of this is r equal to 90 mm. 90 mm will consider, and then draw an arc for 180 degree, 100 degree. And then after that, from the one end I will be considering a radius of say 25, then drawing a smaller circle. Okay, and then the procedure starts. Okay. Okay, here using compass I'm measuring the length of 90 mm, because we have the, you can see in the question, we have the diameter of 180 for the bigger circle. The radius will be 90. Okay, measuring that. Okay, after measuring that, you can take any reference point here. Okay, so I'll consider this as a reference point for a 90. Okay, and for this point I'll draw one line, straight line, because we have to draw exactly at 100 degree, right? I'll consider this length first. From this reference point I'll join. Okay, after this I have to take protractor. Okay, so for considering an angle of 100 degree, exactly at 100 degree, say 90, 100 here. Okay, so here also draw one line. I'll mark a point. So I'll draw another line here. Okay, so I'll complete this arc. Okay, so it is exactly having an angle of theta equal to 100, which we have been find out, and this capital R. Okay, to show that it is of length capital R 90. Okay, 90 mm. This is done. Now the same way, so here we have to draw another circle which is of radius 25. So you can see in this question, small d we have, that is 50 means 25 mm we have to consider. So for that I'll take from the scale, measure 25. Okay, so here 25. So here if I extend in a straight line, so I have to extend here only. I'll draw on the circle which already we have measured it for 25 mm. Okay, here can give this is smaller 25. Okay, so what I'll do, I'll be extending these lines. I'll be dividing this circle into 12 equal parts. Okay, so here as a reference you can see, so here we will be dividing this circle into 12 equal parts, means 30°. Okay, 30, 60, 90, 120, 150. Okay, I'll be extending as I'm drawing the lines. Okay, so we have divided the circle into, okay, 12 equal parts. Okay, so after this, so we can give the naming here. We can give here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so what we have to do is we have to measure the length from here. Okay, to extend from all these points. Okay, I'll be extending this one first. Okay, so this is first point is done, the extreme corner. Now from point number 7 measure. Okay, next now point number 8. Next point number 9. You can see that is our center point. No, point number 9 we have to take 9 and 3. Next point number 10, 10 and 2 same. Next point number 11. Okay, so this is we have completed. Now again we have to divide this 100 degree into 12 equal parts. Okay, now we have to divide this into 12 equal parts. So we have the angle of 100 degree. So if we divide into 12 equal parts means we'll get 8.33 degree. So first what we do, we are going to divide this thing into 8.33 degree. Okay, in between I'll take. Okay, okay, after this I'll take a compass. I'm going to divide this by measuring this length. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I think it's not possible. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have to take a little more than that. So this method we call as a trial and error method. Okay, so I'll take little more than that. Okay, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I think how much? 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12. So little again more than that we have to take. Okay, so divide into little bit more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I think I'm taking a little more here. I think it's also not possible. Little less. I have to take 1, 2, 3. Okay, so this method we called it as a trial and error method. Yeah, after trial and error method we are getting this 12 equal parts. Okay, now from the center, measuring this distance from the center, we're drawing one line. The center will be remaining same, right? So I'll be drawing that, and then now I'm going to extend these lines, okay, to the center. Okay, here 1, 2, 3, 4, 5, 6. the naming for this. Okay, 1 2 3 4 5 6 7 8 9 10 11 12. Okay, can give C1, C2, C3, C4, C5, C6, C7, C8, C9, C10, C11, C12. So this will be 1 2 3 4 1 2 3 4 5 6 7 9 10 11 12. Okay, now by measuring the distance of this radius. Okay, now we have to cut the arc. Say from this C1, so we have to cut here. This is first point. Next from C2, next from C3. Okay, the length will be same. Okay, then C4, C5, C6, C7, C7, C8, C9, C10, C11, and C12. Okay, so now you have to join these points. I can give these points name. So I'll write this one as P1, P2, P3, P4, P5, P6, P7, P8, P9. Okay, P9, P10, P11, finally P12. So now I have to join this. First I'll draw with the pencil and then we can dark. Okay, from here 1, P1 to P2, P2 to P3, P3 to P4, P4 to P5, P5 to P6, P6 to P7, P7 to P8, and then here P8 to P9, P9 to P10, P10 to P11, P11 to P12. So now we can dark this. Okay, can use the same sketch here. Okay, this completes the epicycloid. Now we have to draw the tangent here. So for the tangent, you can see draw the tangent and normal at the epicycloid at a distance of 135. So that means we have to measure a distance of 135 from the scale. Okay, so we can measure 135. Okay, then can cut an arc from here, from this point. Okay, so this point we call it as a M. Okay, now we have to measure this radius, that is 25 mm. Okay, from this point exactly it has been cut. Okay, cut an arc on this center line, and this point we consider that as a x. Okay, now you join this with the straight line. Okay, and where exactly it is cutting, give this as n. Okay, so now we have to join this m and n with a straight line. So n dash will give. Now by using protractor here, exactly at this point I'll march. Okay, mark for 90 degree. And here I'll be drawing one tangent line. Okay, tangent line. This is our t, this is our t dash. Okay, so this completes the problem. You can subscribe for the channel and hit on the bell icon for the latest notifications. Thank you all. Thank you for watching the video.